Hello, Algebra 1. Ooh, I was trying to focus this, but there's like a light. It's like, there it is. That's a little bit better. We're just gonna, I don't know. I'll try and figure out something with this light. I didn't figure anything out, but I think you guys will still be able to read it. Okay, so we are continuing with quadratics today, and we are going to continue with solving. So today we're going to use another method. So last week you guys solved by factoring. This week we're going to solve by square roots, and then the next video for like tomorrow is going to be quadratic formula. Okay, so let's get into it. So just as a refresher, the solutions to a quadratic are the points or point, because it can really, it doesn't have to be 2 points. It could be 1 point, or actually it could be no points at all, at which the parabola crosses the x-axis. Okay. These are also known as, so what are the other words that we use for solutions? So think about those other words. What are they? And if you're thinking x-intercepts, you're correct. So that's 1, zeros, or roots. Okay, so those are my synonyms for solutions. So if you ever see like solve, or if it says find the x-intercepts, if it says find the zeros, find the roots, find the solutions, those are all meaning the same exact thing. Okay, so like I said, we're going to start today by talking about using the square roots method, and that's just like it says, using square roots to solve. And what you guys really need to make sure with this one that you remember is simplifying radicals. So from last unit, you guys had a quiz on it. Is just simplifying the radicals, making sure you understand that aspect. So we use this method when there is no b value. And so what I mean by no b value is your quadratic in standard form looks like this. Y equals ax squared plus c. And so what that's like missing is there's no x term. So there's typically in the middle here, there's like ax squared plus bx plus c. And we use this method when that bx term isn't there. And then, of course, as we all know, with solving using any method, we, so far, just like with factoring, to solve, we're going to set y equal to 0 and solve for x. That's always what we're doing when we're finding our solutions or x-intercepts. Oh, that light is super bad. I fixed it. Okay, so to solve, and this is every single time with x-intercepts. So to solve, we set y equal to 0 and solve for x. And that's like, you know, for x-intercepts, we set y equal to 0 and solve for x. And remember, with our y-intercept, we set x equal to 0 and solve for y. So it's just the opposite. And then remember, when you take the square root of a number, the answer is always plus or minus. So an example, and what I mean by that is if we say, what's the square root of 49? Well, it can be 7, what we know. And it can also be, when we're solving, -7. And so often, like, you'll see me write it as plus or minus 7. So the reasoning behind that is 7 times 7 is 49. And then -7 times -7 is also positive 49. So when we're solving something by like square rooting something, we're like undoing it to get the x by itself or whatever. what's really important is you take into account both sides, is the positive and the negative. So that's going to be super important and play a huge role in our problems here. Okay, so I have an example. I'm going to write the steps out next to it. So the first step is to get the x squared term by itself on one side of the equation. So get the x squared term by itself on one side of the equation. Now, before I do that, I want to point out that our equation is already set equal to 0. I already did that step for you. I replaced y with 0, and now we're just solving for x. So these are my steps to solve for x. Okay, so that means the x squared term, we need to get that by itself. Oh, wrong side. And so the x squared term is here. So I want you to think, what's the first thing I would do to get x squared all by itself on one side of the equation? And if you're thinking we would move the 48 over, you would be correct. So it's a minus 48, so we're going to first add 48 to both sides of the equation. And I get 3x squared equals 48. And I think, okay, did I get the x squared term by itself yet? And the answer is no. There's still a 3 attached to it. So before moving to the next step, we have to get rid of the 3 by dividing both sides by 3. So then when I divide both sides by 3, I have x squared equals 48 divided by 3 is 16. Okay, so now that the x squared is by itself, our second step is really to undo the squaring. And we think, what's the opposite of something being squared? And that's square rooting something. So we take the square root of both sides. Because remember, whatever you do to one side of the equation, you have to do to the other of the equation. To solve for x. Okay, so like I was saying, to undo this square, because ultimately our end goal is to get x by itself, but it has this square. To undo that square, we do the opposite. And the opposite of squaring something is square rooting something. And whatever I do to one side of the equation, I have to do to the other. So I think, what's the square root of 16? Well, I know it's 4, but remember, it's plus or minus 4. And then our last step, and it's a step that is important, and we're going to write it in some of our answers, and we're not going to write it. But the third step is the third step in factoring to write the solutions as ordered pairs. Yeah, I mean, you're always going to have 2, so I shouldn't have put pairs, but, well, technically you could not. So remember, as an ordered pair, you'd write it as x comma 0, because the y for an x-intercept is always 0. So at the x-intercept, the y value always equals 0. So that's why we can always assume that the y is 0. Okay, so let's get into some examples. Oh, I didn't write my actual answers. So as ordered pairs, that would be 4 comma 0 and negative 4, 0. And that's it. So we solved by square roots. Square roots to me is like one of the easiest methods when I see that there's like no b of x term. I'm always happy because I know that it's going to be very quick. Okay, so let's look at number 1. Number 1 says x squared minus 16 equals 0. So it's, like I said before, like all of these examples, your y is already going to be set equal to 0, and you're just going to have to solve for x. So first thing we want to do is get the x squared by itself. So I want you to think, how would I get that x squared by itself? And that would be adding 16 to both sides of the equation. And I'm left with x squared equals 16. So now that x squared is all by itself on one side of the equation, so now I want to undo the squaring. So to undo the squaring, I square root both sides. I'm really at the same exact spot I was here. The square root of 16 is plus or minus 4. So to write that as ordered pairs, it would be 4, 0 and negative 4, 0. And that's it for 1. Okay, so what I want you guys to do is I want you to look at 2, and I want you guys to do the first step on your own. So what's the first step that you would do on your own here? And if you thought move the 100 over, you would be correct, and that's exactly what I did. So from there, what's our next step? So take a second, think about your next step, and what would you do from there? And if you thought square root both sides, you would be correct. And then I think, what's the square root of 100? The square root of 100 plus or minus 10. So then written as ordered pairs, that would be 10, 0 and negative 10, 0. And that is it. Okay, so let's look at 3. 3 there. You have same setup, right? We have x squared plus 25 equals 0. So what's our first step? Our first step is to get x squared by itself. So I would move the 25 over. And I get x squared equals negative 25. So then to undo the square, I want to square root both sides. Now, here's a problem. What's the square root of negative 25? Well, we can't take the square root of a negative number. There's no two exact same numbers that are going to multiply together to get me negative 25. Negative 5 and negative 5 gets me a positive 25. Positive 5 and positive 5 get me a positive 25. And negative 5 and positive 5 aren't the same exact numbers. So what's my answer here? Well, my answer here is no solution. And again, that's because you cannot take the square root of a negative number. Now, what does that mean on a graph? So if you were to actually look at what that means on a graph, I'm going to graph that for you as a parabola. That would be x squared plus 25. Now, look at, this is my x-axis, and this is the parabola. It never crosses the x-axis, which is why it means like why we have no solution there. No x-intercepts, no solutions. It's above the x-axis, or it could possibly be below it, and it just never crosses it. So that's what a no solution means. So no solution means the parabola does not cross the x-axis. So no solution means the parabola does not cross the x-axis. Okay, so what I want you guys to do, I want you guys to try 4 on your own. So pause me here, try 4 on your own, and then come back and check to see if you got the right answer. So you should be coming back at this point to check your answer. So now when we look at our answer, you move the 7 over, take the square root of both sides, but because you're taking the square root of a negative number, it's no solution again. Okay, so let's try number 5. Number 5, again, first step, always our first thought, is to get the x squared by itself. Again, there's no bx term. There's no x term in the middle there, so we don't have to worry about that. That's like if we had that, we wouldn't be able to use the square roots method. So my first step is to undo any addition or subtraction. So I'm going to add 126 to both sides. And so I get 2x squared equals 126. Still got to get that x squared by itself. So that means I'm going to divide both sides by 2. And when I divide both sides by 2, I get x squared equals 63. Now, with this one, okay, so to undo the squaring, we're going to square root both sides. But 63 is not a perfect square. So this is when, like, last unit stuff comes into play. We have to think about simplifying the radical. And that is something that is, like, that you have to do. You have to think about simplifying the radical to get your correct answer. So I think, what's a perfect square that goes evenly into 63? And that's going to be 9 times 7. And I know, well, the square root of 9 is 3, and then I don't know the square root of 7. So that means, okay, I'm going to bring it back up here. X is going to be equal to plus or minus, still plus or minus. The square root of 9 is 3, and then we leave the square root of 7 inside the radical. Now, if you were to write that as an ordered pair, the way that you would write that is just 3 rad 7 comma 0 and negative 3 rad 7 comma 0. So nothing different. It just has a radical in your answer. Now, I know that we can get this as a decimal form. And if I were asking you to graph it, I would want you to get it as a decimal form. But because we're just getting the solutions, this is my exact answer. 3 rad 7, negative 3 rad 7. If we wrote it in decimal form, we'd have to round it. And whenever we have to round something, it's no longer an exact answer. Okay, so what I want you guys to do, I want you guys to look at 8, and I want you guys to try 8 on your own. So try as much of it as on your own, and then come back and check your work and see how you did. Okay, so you should be coming back to check your work because I've done mine. So now you're just coming back, checking to see if you did it correctly. So first thing you should have done to get the x squared by itself is to add 6 to both sides. So I have negative 8x squared equals negative 24. Still need to get that x squared by itself, so we divide both sides by negative 8. And then negative 24 divided by negative 8 gets me positive 3. To undo the square, I need to square root both sides. And then I get plus or minus 3. Now, this is how you can write it if you didn't write it as an ordered pair. You could write it as x equals plus or minus rad 3. You could write it as rad 3 comma negative rad 3. You could write it as rad 3 comma 0, negative rad 3 comma 0. However you want to write it is totally fine. Okay, let's look at 7. Only have 2 more, and then we're done. So number 7, same thing. We're always trying to get x squared by itself. So my first step is to subtract 10 from both sides. and I get 25 x squared equals 36. Still need to get x squared by itself, so I'm going to divide both sides by 25. Now 36 over 25 can't be simplified, and that's okay. We're going to just leave it as that 36 over 25 because I know what my next step is going to be. X squared, we need to undo that by square rooting both sides. And I recognize both top and bottom are both perfect square roots. So I can just think, well, what's the square root of 36? Well, that's going to be 6. What's the square root of 25? That's going to be 5. So my answer is going to be x is equal to plus or minus 6 over 5. And that's it. That's your final answer. Again, you don't always have to write it as an ordered pair. I often won't. I'll just write it as x equals. It's whatever you feel most comfortable with. Okay, last problem. I want you guys to look at 8. I want you guys to try 8 on your own and then come back and see if you did it correctly. So pause me here, come back, check your work. Okay, so you should have already done this part on your own. We're getting x squared by itself. So when we get x squared by itself, we have to divide both sides by 36. Now, there's 2 ways that you guys could have done this. I did this as I just took the square root of both sides, and then the square root of 100 is 10. The square root of 36 is 6. So I got 10 over 6 and recognized that I could reduce that and I get my answer. You could have also reduced it here. And if you did that, you would have reduced it. You could have first, divided it by 2, but there's actually a bigger number that goes into both 100 and 36, and that's 4. 100 divided by 4 is 25, and 36 divided by 4 is 9. So the square root of 25 is 5. The square root of 9 is 3. It gets you to the same answer. So you can simplify either before or after. It doesn't matter. You should still get to the same point. And that does it for solving quadratics by square roots. I hope you guys are having a great day. I just, over here watching a lot of television. I finished last week. What's that new one called? Oh, Outer Banks on Netflix. It was good, but it was fine. It wasn't my favorite. And then I finished Never Have I Ever. That one was cute. I liked that one. So if you haven't watched those are, hot tips here. So I hope you guys are doing well. If you guys need anything, please come to office hours. And that's it. Hope you guys have a great day, and I will talk to you guys soon. Bye.